welcome to the Cannabis Cultivation and Science Podcast. I'm your host, Tad Hussey of KIS Organics. This is the podcast where we discuss the cutting edge of organic growing from a science-based perspective and draw on top experts from around the industry to share their wisdom and knowledge. Our guest today is Tim Wilson of Microbe Organics. Some listeners may know him better as Microbe Man from his helpful posts on many internet forums. Tim is a longtime friend and colleague who has taught me much of what I know regarding microscopy and evaluating compost teas. I consider Tim to be one of the foremost experts and researchers on aerated compost teas and microbial amendments in North America. Tim also founded www.logicalgardener.org, a free forum for gardeners that is a wealth of information. I am honored today to have him on the show. We have Tim on here today. One of the first things I would like to talk to Tim about would be to hear a little bit more about your background regarding growing cannabis in Canada. You have a pretty unique history there. I'd love to hear a little more about that style of growing and how you did it. If we could start with that, that'd be great.
Sure, okay. I guess starting back around 1995 or so is when I kind of more seriously got into growing cannabis, starting with outdoors and then slowly moved it indoors. And a couple of years after that, I ended up having an association with the BC Compassion Club Society, which provides strictly medicinal grade cannabis to, at that time it was around 1,500 to 2,000 patients. Now it's way up there, who knows. But at the beginning, we just started out doing basically what everybody else was doing with the pots, like a 5-gallon pot under the high pressure sodium lights. And then at the end of when we harvested, we would just dump the dirt out and use it in the vegetable garden or something like that. And then it just started occurring to me that this was kind of stupid to be wasting all that. So we graduated from there to just starting to remix the media as we went along each time, adding some more compost to it. And I should mention too that we had also started out just using typical chemical mixed fertilizers, checking the EC ppms and all that stuff. And we sort of had started at the same time, graduated out of that when we just started using compost and some more natural fertilizers. And at the same time, we had been expanding our outdoor gardens. And in the outdoor gardens, we didn't mix anything up every year. We just left it like as if it was a vegetable garden, and the plants outside were doing just as well, if not better, than the indoor plants. So then I thought, why don't we just try to move outdoors indoors? And so we pretty rapidly graduated to using bins, and I guess that would have been around 1999 or 2000, something like that. The problem being with the bins is that they take up so much space and you can't move them around. So then we just got the idea of building bins which could be stacked on top of each other with the lip sort of facing out, so there was a little space to get into to plant the young plants, the rooted cuttings into, and just hung 3 high pressure sodium lamps in the center, and had the 4 boxes stacked high, and I guess around seven stacks or something around the lights. We just stopped doing any digging up of the soil, just let it be. And, at first I thought there's no way this is going to work, but we experimented with one set. It worked fine. We just top dressed. In between harvests, we would inoculate with fermentations like EM fermentations and that sort of thing. The only prepared thing we were using then was fish hydrolysate. Other than that, we just made our own compost teas. With that system, we would allow the plants just to grow up over about 10 days to 14 days. Then we would just change the light to the 12-hour cycle and then start flowering them. So the whole turnaround time was close to 60 days, 64 days, something like that. The plants were only 18 inches tall approximately when we harvested them, but doing it like that, we got the same yield as we were getting before, where we were growing these larger plants and over a longer period of time. And so we ended up getting actually a higher yield that way. Anyway, I don't know if I described it exactly perfectly or anything, but ask any questions about that.
Yeah, so I was wondering, what size were these bins that you were describing? And then also, what was your media in the bins that you kept reusing?
Yeah, okay. So the bins were about 36 inches long and 14 inches deep. And at the bottom, they were about probably 10 inches wide, and then where they sloped out to about 14 inches at the top. And making the initial mix, we found over time with experience after we started the other bins is fairly important. We tried to have a combination of things that stay in place for drainage for a longer period of time, over the life of the soil, basically. So we use things like fine gravel and pea gravel and that sort of thing. For that component, intuitively, I just thought, let's use as many different colors as we can. Whether that makes sense scientifically, who knows? But just in keeping with the human diet, that supposedly if you eat a variety of color things, you get a variety of minerals and nutrients. So that was my idea with that. And then of course we mixed in sphagnum peat moss and topsoil from outside, and vermicompost that we raised ourselves in a big heap in the barn. Full of worms.
Can we talk about that too, Tim?
Yeah.
You have a unique vermicomposting style, and I've seen the microbial results of your vermicompost, and it's always fairly superior to pretty much everything else I see. I'd love to share that with listeners too.
Okay. Well, so do you think I finished off the mix there satisfactory? I mean, I know it's my way of doing it is quite different, and really I count on the soil coming to life and having a life, that's ongoing. So the microbial population stays in there and doesn't get disturbed. And I think that's really what contributes to the success of the whole thing. And I should add, too, that as far as pests go, like insects that chow down on the plant and root suckers and stuff like that, we were really fortunate in that when we brought in some of the topsoil and the vermicompost from basically outdoors, we also brought in some rove beetles. And they were just indigenous to the area, and they basically kept the pests in balance. It was just amazing that we had success that way. But in addition to that, we bought some cucumeris and some persimilis, and both of them. We also had another room where we had 18-hour light going all the time. And both of them multiplied on their own. Why, I don't know exactly. I didn't give them anything special to eat or anything like that, but especially the cucumeris just propagated like crazy. So whenever we needed them in another room, we would just dig some up and take them in and move them around. So, and I should mention that the longest time that we had those bins going without mixing up the soil was 7 years, and the other ones were about 5 years, and they just got interrupted because our contract was questioned by the authorities, and we had to sort of shut down. But with the vermicompost, we had two different methods that we used for that. One, like I said, was just done in a big heap in a small barn that we had built for that purpose. And we piled up horse manure that we got from our field. And we usually pick out the stuff that's semi-dried out, and mixed in some sawdust and straw sometimes, but it was almost all horse manure. And into that, we would mix some wheat bran that was very cheap to buy at the livestock supply store, some alfalfa meal at no greater than 5%, because I found out the hard way that if you put too much alfalfa meal in, the nitrates just kill the worms. And we also put in some peat moss into that. And I didn't say kelp meal yet, did I? Kelp meal as well. So we put in as much kelp meal as we could afford to at the time, but which wasn't very much because it's more expensive as an ingredient. But the important part with that is that we left it for a long time. So basically, our worms were neglected. We didn't harvest it out on a continuous basis. So my opinion is that because the worms were sort of forced to keep on redigesting what was there and to digest every little scrap they could find instead of having new food given to them, they produced a superior quality. And our vermicompost was not typical looking like the castings that you see in the bags. That was sort of real gooey, gummy stuff anyway. And then the other method is that we use basically the same ingredients, except added kitchen scraps as well, and raised them in big plastic bins, but also subjected them to, staying in there for a very long period of time. Our method of harvesting the worms out was to use those plastic mesh transplant trays. We would just fill them up with the worm's favorite food and cover that over with wet newspaper and then lay them all over the top of the worm pile. They would crawl up in there, and then we would just snatch them off and then gradually throw them all into a big bin and then come in with the tractor and clean the barn out. Obviously, we also scooped out some of the worms and the castings, of course.
So one of the things that you've talked about already was just the importance of the microbial communities in the soil as being the most critical factor for allowing you to have this system where you could go 5 to 7 years without disturbing the soil. Could you give listeners a little background into the microbial loop, or living soils as you call them?
Yeah, sure. Okay, so first off, with a living soil, there's, microbes live hierarchically, so that there are some microbes that have evolved to function close to the surface of the soil, and some halfway down and some way down at the bottom, where there could be rocks or whatever. And so the ones that are at the surface are the ones that decompose things the fastest, and scientifically it's called the detritosphere, where detritus, shit and all that, branches and leaves and everything fall on there. And so they have at their disposal all kinds of fuel. You know, they can use the oxygen, which is abundant, nitrogen is abundant, you know, light even that some microbes use is there too if they need to. So that's why that's the fastest area that things are degraded. And then the altered component of what was degraded is then passed down to the next set of microbes, et cetera, et cetera, et cetera. So that's sort of a basis of why you want to leave your soil intact. And then, you know, if you're outside, or if you put some sort of rocks or minerals at the bottom of your soil mix, then possibly you have the mineral microbes that will therefore pass some minerals up the scale instead of down the scale. As far as the actual nutrient loop goes, the biggest players in that are the bacteria and archaea. I should take a minute to say that archaea I lump in with bacteria because they're absolutely indiscernible if you're looking at them with a microscope. And for many, many years, we've thought that it was all bacteria that we're looking at. It's only been in, you know, the past 20 years and, you know, getting more and more that people are discovering that archaea are everywhere, and that maybe they are just as or even more responsible for the mineralization of nutrients. But anyway, so I put those together, bacteria and archaea. They process organic matter or minerals, and then they are consumed by protozoa. And in the protozoa group, the two important ones in our soil that we're looking for, flagellates and naked amoeba. And so they use only 10 to 40% of the energy that they intake from eating those other organisms, and the other 90 or to 60% is expelled in an ionic form that's directly available to the roots of the plants. That's really an economic thing for the plant, because then it doesn't have to expend as much energy to gain nutrients. You know, that would take us into another topic to talk about root exudations, but I don't know if we want to get there quite yet. But I don't know if I explained that as simply as possible, but to put it in a nutshell, the protozoa eat the bacteria and poop out ions that the roots can uptake that are already, you know, in a form that is available to them.
Yeah, no, that's great. I think the way I usually explain it is when we're putting out Miracle Grow or any kind of, you know, chemical or ionic nutrient, we're directly feeding the plant. That's coming in direct contact with the roots, plant grows. When we put out organic fertilizer like alfalfa meal or kelp meal, we're not directly feeding the plant, but all this microbial interaction is what causes these nutrients to be changed into a form that the plant can then uptake.
Yeah, true. That's exactly what happens. And you know, if we do get into this a little bit, the bacteria, archaea, and fungi that initially degrade the nutrients have organic acids that they excrete for that purpose, and the plant roots have the exact same organic acids that they utilize, or very, very similar anyway, to to release nutrients as well. That's how plants could do it without the organisms there to cycle the nutrients. You have some of the nutrients which are stored in adhered to these organic matter or clay particles are stored as everyone knows as cations, and they have certain net positive charges. A lot of guys talk about how you have a certain balance of soil, and along comes another charge, and lo and behold, the nutrients is released from the organic matter or the clay, and is then available to the root. But it's not 100% that simple, or maybe it is simple, but it also occurs from it's caused by the organic acids I talked about. So if you have, say you have like calcium, it's got a +2 positive charge. So we've learned that it is released by hydrogen. So if we look at one of the organic acids, say citric acid, which is very common, it has 8 hydrogen bonds on it. So if you consider that if you divide the 2 into the 8, we get 4. So that means that the citric acid could release basically 4 units, for want of a better word, of the calcium nutrient. And so these organic acids are actually released by the roots and by the microorganisms. It isn't something that just happens because of having a certain mix in your soil, at least in my opinion. So do you follow what I mean? Or is that too crazy?
So these organic acids that are produced both by the plant roots, as in the form of an exudate, or by these microbes in the soil, you're saying is what's essentially making these various plant nutrients available to the plant in an ionic form. It
is actually what releases from the where it's stuck, the cation exchange capacity, mm-hmm. right, where it's stuck to the organic matter or the clay particle. So that it's the trade of the hydrogen atoms that make up that molecular structure that actually releases equal amount of nutrient from the positive charge cation.
Sure. So
it's the roots of the plant and the microorganisms that are making that happen.
That's why I would say it's important in your soil mix to have a microbially active media, meaning adding in vermicompost or having a high quality compost fraction in there, as well as a good peat moss is a good way to increase that nutrient cycling. Would you agree?
Absolutely. And like with peat moss, it's got a really high CEC, so it has a large capacity to hold nutrients, which are then available on an ongoing basis.
Yeah, so the plant can control what nutrients become available both by the exudates that's feeding to the microbial populations in the rhizosphere, as well as the organic acids it's using to break down some of these nutrients itself. Is that correct?
Yeah, basically, it's kind of it's complex beyond complete simplification, but in my mind, I've sort of simplified it in even though the roots can excrete these organic acids to get the nutrients themselves, they can also excrete amino acids and sugars that attract certain bacteria to them. And so then by attracting and feeding those bacteria, the bacteria increase vastly in population very quickly. And so that stimulates the protozoa to come out of their cysts, to exist, and then they begin dividing. So as the bacteria release the basic nutrients that we talked about with the excretion of their organic acids, and then the protozoa begin feeding on them, they basically multiply the amount of nutrient that would have been available to begin with. So for the economy of the plant, it makes great sense that it has released this energy in the form of the amino acids and sugars to start feeding these bacteria to begin with. It's almost like when you watch a compost tea developing, right? When you start it up and then you feed it some molasses or whatever food stock, and the bacteria are just about the first thing to begin multiplying. And then because of that, the existence of all those bacteria, it stimulates the protozoa to come out of their cysts and to begin to divide as well. So it's kind of the same thing is going on, but it's in the soil.
So let's talk about this before anyone takes this concept and starts dumping sugar all over their plants. Can you explain a little bit more about maybe a little bit about molasses and different sugars, and then also what happens when you put too much, and what happens when these bacteria reproduces too rapidly?
If the bacteria produce too rapidly, you mean in the soil, or do you mean in a compost tea?
I want to save compost tea for just a second. I'm talking about just in the soil. I'm kind of leading you to a question, but I think you're going to get there. So what happens if we add, let's just say, too much molasses into a soil? What's going to occur?
I'm not really sure. I can't say, and I don't know what too much is, but too much of anything is not good. And so I would just guess that if you put too much molasses in there, you'll get an overabundance of bacteria, and they may end up eating everything in sight. It depends on what you have in the soil to begin with, because molasses is a food for fungi as well as bacteria. So it does make some sense to just apply some diluted molasses occasionally to soil. They use molasses. I don't know if you know about this, but if there's like an oil spill out in a wilderness area, they pour diluted molasses into the soil to stimulate the bacterial population that will consume the oil.
I didn't know that. No,
Yeah.
what I was getting at is you have the potential for the bacteria to multiply so rapidly that they could actually create a temperature increase in the soil around the root zone, which could cause the plants to suffer, or that the bacteria could be more efficient at accessing that food source to where it could pull nitrogen and other nutrients from what the plant could access.
Yeah, that's a possibility for sure.
That's kind of what I was trying to get at, just to caution listeners.
Yeah. Well, you caution with everything. The same thing can happen if you put mix like wood chips or something into your soil. Wood chips that are not composted or aged. The same thing can happen. The bacteria and maybe fungi will use up all of the available nitrogen in an effort to degrade those wood chips, and so then they lock it away from the plant. That's why I don't like the idea of burying things down in the soil for the the plant to come upon sometime in the future or whatever. Because that's always a possibility for that to occur if you put some sort of raw organic matter down there that is not stable.
Are you talking about hugelkultur beds, or are you talking about the layers that I've heard some of the Rev had recommended with the True Living Organics?
Oh, yeah, the layers sort of thing, the spikes. Some guys say that they have great success if they put a dead animal at the bottom of the pit before they plant and stuff. And sometimes that works out great. It's just it almost seems like it's happenstance that sometimes there's a lockup and sometimes there isn't. I've been caught for sure with my pants down with that one by mixing stuff in too soon.
Okay, so let's change direction a little bit here and talk a little about soil testing. So I know that certain groups, like in the past, I've heard some people claim that all the nutrients we need are already in soils, we just need to add the right microbial populations, they'll make these nutrients available. While there's other groups that will say, hey, if we get the right mineral content and balanced in the soil and everything is, the soil is minerally balanced, then these microbes are just going to appear and start reproducing, and then we'll have optimal soils. Can you give me your sort of take and experience on all of this?
Well, I don't think that every soil everywhere will produce whatever you need just because it has a good microbial population. There may be certain soils in some areas that you can say that about. I'm in the group, or maybe by myself, where I think it's important to include as many diverse nutrient components as you can within reason, and that's why we used so many different things in our soil mixes, like we would take stone from one area and use the vermicompost and that sort of thing, and that's what I think is necessary. I haven't bought into the whole balanced soil thing because the way I've been looking at the way that plants and microorganisms work together to acquire the necessary nutrients sort of goes against that in my mind. Because I think what you're saying when you say if you have a balanced soil and then all of it'll cause this to release that and this will be available instead of being locked up, and it sort of goes against the plant being sort of having an influence over its environment, and as if it's just something that's being held up and sucking up nutrients. Whereas I think it really does work kind of the way I described, that the plant is working in concert with the microorganisms and the organic materials that are around it, and those can be organic matter, can be compost, vermicompost, powdered rock, minerals, clay powders, whatever. So that's why I like to put within reason as much as I can, but balance it as far as the soil being able to breathe and drain and that sort of thing at the same time. I don't know if I answered your question or not.
You did and you didn't. So the physical properties of the soil, totally agree with in terms of the amount of porosity, drainage, aeration. When we talk about a soil, though, let's say you have a soil that is deficient in calcium. That calcium has to come from somewhere.
Yeah, absolutely.
So there is something to balancing the soil and saying, hey, I just did a soil test. This is obviously low in calcium. I need to raise my calcium levels up to X, whatever that level is that you want to set it at. I totally agree with you in terms of the fact that mineral balancing is just certain people's best guess, whether it's, Kinsey, Solomon, Michael Estera, All of these guys are just, Carrie Reams. They're trying to guess at what they think is optimal for plant health for various crops. But we don't know. There just hasn't been enough research, it seems like to me, in that regard.
Yeah, well, so I haven't said that you shouldn't have calcium or you shouldn't have all of the components possible. What I am saying is that they should be there, but they don't necessarily have to be there in the certain ratios that someone has delineated.
Sure.
Yeah, that's all. So, and sure, you could end up with some soil that's deficient in calcium, and then sure, you need to add some component in that's going to supply the calcium. Absolutely.
So you're saying don't get too caught up or freak out if your potassium is not at 3 to 5% of your CEC, or your calcium is not 60 to 70%, and all of that sort of thing.
Yeah,
right.
That's what I mean. Yes. Whether I can't say that I'm 100% right, but that's how I grew. But definitely, you try to include everything that you can, and it all depends on an individual's circumstances. Some people can afford to send away to Timbuktu for whatever ingredient, right? Others, like where we were on a farm 90 miles away from the closest town, and so we used what was at hand and made what we could make. Lucky, I guess, we did have all of the necessary components existent in the materials that were around the area.
We talked a little bit about soils, and you talked about the importance of these microbial communities in the soil. The way I met you was actually through a discussion board hosted by Jeff Lowenfels on Aerated Compost Teas. And I consider you one of the foremost experts on the continent when it comes to this subject. So I would love to kind of dive in a little bit to that if you have time right now, to discuss a little bit more about what aerated compost teas are, what they are not, and what you would recommend for people that are just starting out in using compost teas.
Okay, so what is aerated compost tea? It's basically a water base that's got air being pumped into it, and it's being agitated, and compost is added, and the agitation extracts the microorganisms that are existing in the compost or vermicompost, and a food source is provided that feeds the bacteria, archaea, and fungi that are existent in your compost. And as they multiply, it stimulates, as I said before, the protozoa to come out of their cysts and begin to divide and multiply as well. So over a period of time, the population expands and reaches a sort of an approximate ratio where you have you can see if you use a microscope, lots of bacteria and protozoa. The protozoa are eating the bacteria. So that's when the nutrient cycling is occurring and it's at its peak. And if so, that's your purpose for using the compost tea, that is the time to apply it.
Now, what's the window when that generally occurs?
For me, 36 hours is pretty safe. If you're not using a microscope, that's a good time. People talk about different recipes and making a fungal tea opposed to a bacterial tea, and anyway, it doesn't really work that way as far as recipe goes, although you can have some influence with the recipe. It's more the timing. So obviously, if you want to have straight bacteria in a tea, it's going to be in the first probably 12 hours that you want to use it. However, if you do have fungi in there in your compost, it's going to be growing at that time as well. So I've never successfully managed to have a compost tea that was either fungal with no bacteria or bacteria with no fungal, if they both exist in the compost used. They pretty much grow at the same rate, at least in what I've done. So if that's what you want, then you want to probably use it between 12 and 18 hours. But it after 24 hours is usually when the protozoa reach their peak, or start multiplying, I should say, and reach their peak at 36 hours. And so if you want a nutrient cycling, that's when you use it. As far as methods of making compost tea, we made everything. We made everything from 1 liter brewers up to 1,200 gallons. We had straight air stones. We had others that were copies of what other people had made, with the air going down a cylinder that had the compost in it. We used venturis, which are made with water pumps, and airlifts. And airlifts are the most successful way of doing it for sure, as far as agitation and as far as dissolved oxygen. There's mathematical papers that illustrate an airlift can up the dissolved oxygen capacity tenfold from an air pump that's just blowing into air stones. Anyway, should I get sidetracked there and forget what I was saying, or what?
No, I think that's interesting, and I want to reiterate that when Tim says that he's tried all these brewers, you've also looked at them under a microscope, and you spent hours and hours in your laboratory. It's not a matter of you just looking at a bucket of brown water and saying, "Oh, this looks good," or throwing it on a plant. You're actually spending time looking on slide after slide and examining all of these teas.
Yeah, we took the pH and the TDS and everything. Every single brew. I've got several notebooks still full of all of the notes from there, and took the dissolved oxygen readings, of course, and temperature and the whole works.
I want to back up just a little bit. One thing you were talking about with this bacterial dominated or fungally dominated teas, I just want to make it clear, when we talk about a tea that's fungally dominated, there's still going to be a ton of bacteria. It's not like you mentioned briefly, the bacteria is not going away and vice versa. And it's really the brewing length that controls that more than the recipe, right?
Absolutely.
Great. So I just wanted to clarify that. And then let's talk a little bit about what happens when you brew perpetually, or you brew longer than 36 hours. Because I know this is something that certain companies in the industry are promoting that you and I feel rather strongly about already. So let's talk about what happens on a microscopic level.
Well, if once you go beyond 48 hours is pretty much a maximum before the ciliates, usually ciliates, start taking over the whole thing. Sometimes it's the flagellates, but in most of my experience, ciliates start coming into play. Ciliates are the larger protozoa that are sometimes an indication that there are some anaerobic bacteria in the picture, because that's their favorite food. Like if you go up to 72 hours or even beyond that, you just end up with a ciliate soup. I've got some video footage that, I don't know if I ever showed it to you, but it blows my mind. It's just like the whole slide is just teeming ciliates. It's just amazing. If there's someone who has a perpetual brewer going in a store and then selling tea to customers, I mean, that's possible to do, but every 36 to 48 hours, you really should reconstitute it. And so that means put in some more compost and put in some more feedstock. But what happens is that once you do that, you're going to have to wait for, 24 hours for it to basically go through the whole cycle that it goes through to come back to being a useful product again. So if you're a perpetual brewer and you're selling tea, pity the customer that comes in after you've just added new stuff to your brew. They're going to get something that the dissolved oxygen hasn't had a chance to build up and the microorganisms haven't been properly extracted or multiplied. They're going to get a totally different product from the customer who gets it at 36 hours. So that's what's wrong with perpetual brewing. If you're doing it for yourself at home and keeping track and you have a microscope or even you just want to experiment, go for it. But if you're selling it to somebody, that's just not very kosher.
You bring up a point, though. I found it was very challenging to try and maintain good microbial diversity and biomass, even when adding food stock and using a microscope beyond 48 hours. So when we were doing those trade shows together, for example, where we had the microscope and we had a brew going and we would pull samples and add food stock and try and maintain the brew, even with a microscope and looking at the samples every 15, 20 minutes, it was still very challenging to maintain that compost tea. And I didn't really feel like we did all that effectively.
Yeah, no, it wasn't very good. No, you're right. Yeah.
So I totally agree with you. That's why when we brew at our farm, we'll just tell customers compost tea is available on Saturdays, and that's when they can come in. It'll be brewing throughout that day. They can get some to take home, and then we'll shut it down, discard whatever we have, and start over again for another day, sort of thing.
Yeah, that's the way to do it.
So some brewers are putting they're saying they can put compost tea in a fridge. Have you heard of that one? There's a company that's doing that.
Yeah, I've seen. There's all kinds of stuff on YouTube these days.
So I just want to say that doesn't really work very well either. I don't know if you've experimented with refrigeration or any of that sort of thing yourself.
Yeah, we did put some in the fridge when we were doing all of our experiments and stuff, and it wasn't worth a damn. The microbes basically just die or go dormant, and they don't come back again unless you might get them back again if you add it into a compost tea and brew it over again. When we did have to store some tea, we did it with removing the compost, because it was in a case where we had it in a bag, so we could remove it, and then aerate it. And the longest I kept it that way was over a period of 3 days, constantly aerating it, and even then it slowly degenerated. What you say about putting it in a bottle, that reminds me about when people send a sample to get tested, the whole thing is going to change during the shipment. So by the time it's tested, if you're trying to say, well, this sample was taken at 12 or 36 or 40 hours, by the time it's looked at the lab, it's not going to be that time anymore. It's going to be 50 hours or however long it took to get there, and it will have transformed. I don't know if I should say this, but I had a client who was in a bind that he had a big customer for a landscaping deal, who insisted that he would not contract with him unless he had a good test result from a lab. So he asked me what he should do, and so I said, well, just brew for 8 hours, put it in a bottle, and ship it. And by the time it gets there, it'll be good. And so that's what he did, and it was perfect, and he got really great test results and got the contract.
Yeah, I think that is a challenging aspect with the whole idea of testing, and it's really expensive. And I like to point out to people who are doing those types of tests that not only does it have the challenges that you just listed, but you change one thing about your brew, that snapshot really doesn't allow us to make useful decisions in the field in terms of how to improve our compost teas, in my opinion. And that's why I think having a microscope is so useful if you really want to get into that aspect of growing. One thing I do want to bring up that you kind of hinted at there is I don't want to discourage growers from experimenting with compost teas and trying them out on their plants. And it's really hard. It's really hard to truly screw up.
Yeah, it's very difficult to make a bad compost tea.
Yes.
I tried the adage of having an anaerobic stinky tea and dumping it on a plant that I want to kill, and the plant actually loved it. So anyway, one thing I wanted to bring up is recipes. That's something else I've sort of learned in my old age, is that I've seemed to get just as good results from just using vermicompost with molasses. And, you know, I do have the recipes that are on my webpage that a lot of people they say that's what they use. They stand by it. It's great and all that. But, you know, all power to them. And if they like it, stick with it. But for me, I found that I stopped including all of the things like rock phosphate and kelp meal and fish hydrolysate, and just stuck with the molasses and vermicompost, and got exactly the same microbial population growing in there. So
sure. Yeah, we use a product that we call our Microbe Catalyst with ours as a food source, not because there's anything wrong with molasses, but just because it's a dried granule, and molasses is hard for us to package and ship. But when I do a lot of my microscope testing, I actually use molasses, and you showed me that. And I will say I do really like to use organic alfalfa meal in addition to molasses and vermicompost as part of your recipe when I use your recipe. But just the molasses and vermicompost works really, really well too.
Yeah. Well, molasses has got a bad rap somehow. Well, I think it all started with some testing that was done in two different labs. One was a USDA lab, and another was a Canadian agricultural lab, and they were, trying to show that E. coli would grow in aerated compost tea, and I can't remember exactly, but I think both of them had some sort of setup where they were using jars with air stones, which is okay, just for experimental purposes. But they also inoculated, both labs inoculated with E. coli. And so if you put E. coli into an aerated liquid, water, and give it food like molasses, of course it's going to grow. There, any kind of bacteria is going to grow. So that's what I thought was very flawed with it, and it actually, in people's minds became so serious that I think it was what's the organic branch of the USDA called?
The NOP?
Yeah. When they had the Compost Tea Council's part of that, and they, because of those lab results, they said you shouldn't use molasses in compost tea out of all this fear-mongering about E. coli growing. And so it just, that a lot of people are saying never use it because of that. And it's just, in my mind, just a kind of a silly knee-jerk reaction. And as you know, it feeds fungi just as well as it does bacteria. So it's a very useful food stock to use.
Yeah, I would say that's one of the myths that you've sort of helped dispel or challenge over the last decade. Another one is foaming. I know when I first got in the industry, everyone was talking about how you need to have a good head of foam on your compost tea like it was a beer or something. You were able to show from looking under the microscope that that really wasn't the case.
Yeah, well, both things are still rampantly going by rumor everywhere, and it continually I have to keep repeating that it doesn't necessarily mean anything. But
I don't want to keep you for too much longer here, Tim. Really appreciate you taking the time today, and maybe we can do a follow-up interview to kind of hash out some more of these topics here in the future. Thanks, Tim. Don't forget to check out Tim's website, www.microbeorganics.com, for more information, microscope videos, and images. He is the inventor of the 50-gallon microbulator and the 5-gallon mini microbulator, both currently available on our website. He also has a microbe identification DVD that helps farmers in identifying various microbes under the microscope, available on his website for only $40. This DVD was very helpful to me because the microbes don't hold still on the slide, so it is much more useful to see video than still images. You can also read more about Tim's theories and research regarding root exudates at www.logicalgardener.org, a free forum hosted by Tim and myself. You are listening to the Cannabis Cultivation and Science Podcast. I'm your host, Tad Hussey. Stay tuned for future podcasts from leading experts around the industry. Don't forget that there's more information and articles available on our website and blog at www.kisorganics.com. And if you enjoy these podcasts, please take a moment to leave me a review on iTunes and send me your feedback and suggestions through our website contact page.